Our projectile is also an actor. In the header file, I added forward declarations for the required components. Then I added the begin play and the end play functions, as well as two member variables for the mesh and projectile movement components. I also created the onProjectileHit function. In the CPP file, I set the root component and configured some default settings for the projectile movement component. Then, in begin play, I subscribe the onProjectileHit function to the onComponentHit delegate. This means that onProjectileHit will be called whenever our projectile collides with something. For now, it simply destroys the projectile actor. You can hover over onProjectileHit and press F12 to see its signature, which will show all the parameters. Inside standard turret, I added a fire position component to act as the spawn location and a t-subclass of variable for the projectile, so we can spawn the correct object. In the CPP file, I initialize them in the constructor, and inside fire underscore implementation I spawn the projectile. We are ready to set up the projectile, but first let's create a mesh for it. Open modeling mode, select a sphere and set its radius to 2. Then click accept. Navigate to the created mesh, rename it to sm_projectile and move it to the meshes folder. Next, create a projectile folder inside blueprints. Create a blueprint class from our C++ projectile and name it bp_projectile. Select the mesh component and assign the projectile mesh. Scroll to the collision section, set the collision preset to custom and set it to ignore pawn. Then press compile. Now open the turret blueprint and select the turret mesh component. Scroll to the collisions, set the collision preset to custom and set the object type to pawn. This way the projectile will ignore collisions with the turret mesh component. Move the fire position component up slightly and rotate it 90 degrees on the y-axis. Then select the projectile class. Next, open the player blueprint. Select the mesh component, set the collision preset to custom, and set the object type to pawn, just like we did for the turret. Finally, press play and hit space, you'll see the projectile flying. However, it looks a bit dark, so we need to add a material to it. Navigate to the materials folder and open the turret material. Will be used on the turret material as the base parent. Then create a material instance from this material for our projectile. Inside the material graph, create a multiply node and connect the turret color to the A input pin. Next, create a scalar parameter called emissive strength. Connect it to the B input pin, set its default value to 1. Then connect the multiply output to emissive color and save the material. Right-click the turret material, select create material instance and name it mi_projectile. Open this material instance, change the color to orange and set emissive strength to 10 and save it. Next, open the projectile mesh and assign this material instance. Now when you press play, the projectile will be clearly visible. As a final step, adjust the projectile's mesh pivot, open modeling mode and set the pivot to center. We are ready to create our asteroid spawner. This is another actor class. Like always, I started with a forward declaration, then I added a constructor and a post-edit change property function. Notice that it's wrapped inside if with editor, because this is an editor-only function which doesn't exist in package builds. Then I have the begin play and tick functions. Then an array of T subclass of actors, which is used for specifying actor classes to spawn. Then I have min and max spawn intervals. I also added a meta tag that clamps the value between 0 and 100, so we can set values outside of this range in the editor. Then I have a billboard root component and asteroid spline component, which will be used for defining the asteroid spawn region. Then I have the spawn function and the current spawn time variable. Inside the CPP file, I included components and added getSpawnLocation function, which simply returns a random point along our spline component. This function is inside an empty namespace, which basically means that this is a static function. Then I added initialization in the constructor. Then I call spawn function inside begin play, and in tick I decremented the spawn time, and when this is less than 0, I call the spawn function again. In the spawn function, I added some validation to make sure we have at least one class to spawn from. Then I pick a random class, get a spawn location, and spawn the actor. Then I simply reset the spawn time. Finally, I added post-edit change property, which is automatically called when we change any value via the editor. In my case, I check if min spawn interval was changed, and then I clamp min spawn interval since we don't want it to be bigger than max interval. When the C++ logic is done, create a new folder inside actors called managers. Then create a blueprint class from the asteroid spawner and call it bp underscore asteroid spawner. Open it, select the spline component and move it 300 units down. Select the right point, set its type to linear and move it right to 500 units. Then while holding the Alt key, move this point up to 600. Select the first point and set it to linear as well. This can be buggy sometimes, so you may need to set it to something else before you can select linear. Then while holding Alt, move the last point to -500 on the right, and again while holding Alt, move it down to 0. Finally, hold Alt and connect the last point back to the first point. We now have our spawn region. Drop this actor into the viewport, reset its position and rotate it 90 degrees. Next, we need to create an asteroid actor. I've already prepared it, so you just need to make sure a new blueprint from actor class exists in your project. This actor has a static mesh component. I set the scale to 0.5, enabled simulate physics, enabled simulate generate heat events, and disabled gravity and set the collision preset to physics actor. Inside this blueprint, I have several variables: move speed, player location, asteroid location, and an array of asteroid meshes. The array has 6 elements filled with all our asteroid mesh variants. These meshes are assigned to the mesh component created inside this actor. I also created variables for max rotation speed, pitch rotation speed, yaw rotation speed, and roll rotation speed. In the begin play node, I pick a random mesh from the array and assign it to the mesh component. Then I generate random float values up to max rotation speed and assign them to pitch, yaw, and roll. Since random float in range is a pure node, it is called 3 times, which means each axis gets a different random value. In the tick node, I build a rotator from this random speed, multiply it by delta time, and set the actor's world rotation. Then I set player location. To move the asteroid toward the player, I calculate a directional vector by subtracting asteroid location from player location. I normalize this direction, multiply it by move speed and delta time, then add it to the asteroid's current location before updating the actor's position. This makes the asteroid move closer to the player each frame. Finally, I added an on-component hit callback for the static mesh that destroys this actor when it collides. If you don't know how to create this event, click on the mesh component, scroll to the event sections, and select on-component hit. Then we can use this created asteroid as a spawn class in our asteroid spawner. When we shoot an asteroid, our projectiles pass straight through it. This happens because the projectile mesh doesn't have a valid collision. Let's fix that. Open the projectile mesh, go to the collision options and click Add Sphere Collision. Then press Save. Next, enable Simulate Physics in the projectile class and disable gravity. Now, when a projectile hits an asteroid, the onProjectileHit function should be called. I set a breakpoint there and it was successfully triggered. At this point, our project is really starting to resemble a game.